Hi. In this section, I want to talk about power in the context of appliances and electronics. So, power is a really useful quantity when we talk about appliances and electronics. And the reason why is because appliances can be around for decades. So, if we wanted to compare a high energy, meaning high cost appliance, to a low energy, meaning low cost appliance, then it would be really difficult to just talk about how much total energy that appliance is going to use. Mostly because some appliances might live for like 2 3 years while the a different model of that same appliance could live for decades. So the one that goes on and on and on for decades would have a way higher total energy use over its lifetime, but that's just because its lifetime was so much longer. So, if we want to be time independent when we compare these appliances, it would be much smarter for us to talk about the power rating of these appliances. Because, as we know from last lecture, power is a way to talk about energy independent of time. And so, talking about power allows us to talk about these two appliances independent of time. Okay. So in order to do that, what we're going to do is we're going to use light bulbs as an example. So let's look at this example right here. Let's compare the energy used in 1 hour of a 60-watt light bulb compared to a 13-watt light bulb. Okay. And let's do this answer in joules. So I will start with the 60-watt guy. And if I want to find, I'm given information about the power and the time, and I'm looking for the energy. So this is a perfect opportunity for me to use the power equation, put in 60 watts as my power, put in, my unknown of the energy. And then 1 hour, I don't want to put in 1 hour because hour is not the base unit for time. Instead, I need to use seconds. So 1 hour, I believe, is 3,600 seconds. So if I multiply both sides by 3,600, then I should get how many joules of energy this thing uses. And I got 216,000 joules of energy being used by this 60-watt light bulb. Now let's compare that to a 13-watt light bulb. Okay, we're going to use the same equation. Whoops. We're going to use power is equal to change in energy divided by time. In this case, our power is 13 watts. We're going to find that change in energy. Time is the same, right? Because we're comparing these two things over the course of 1 hour. So if we take 3,600, we multiply it by 13, then we get that this light bulb is going to use 46,800 joules of energy. Okay. So if we look at our energy consumption, it's quite clear that this 13-watt light bulb is the winner, right? It is using far, far, far less energy than the 60-watt light bulb does. So if we want to do things like lower our electricity bill, right? So we're lowering our energy bill. We want to choose the light bulb that's going to use fewer joules of energy every single hour. Okay. And again, right, we probably didn't need to do this calculation if we just looked at the power rating of the two light bulbs. Okay. Because already we see that that 13-watt light bulb has a much, much smaller power rating than the 60-watt light bulb. So this is an indicator to us that it should use less energy per time and be the overall cheaper option to power. Okay. Now, if you guys go and actually look at your energy bill, it's really fascinating. I highly recommend that you do it. Go ask your parents for it and just peruse it. Just see what it looks like, see what information they give you because they give you tons of information in that energy bill. And you'll notice that nowhere on that bill are they going to use the unit joule. Okay, instead, they use this thing called a kilowatt hour, which you may look at that and say, I know what a watt is. Why are they telling me a unit for power? However, it is not actually a unit for power. It is a unit for energy. Okay, because we just saw that if we take a power and multiply it by a time, we get an energy. And this unit is taking a power and multiplying it with a time. And thus it is a unit for energy. Okay, so and this is a really good unit because it can make energy calculations really simple. And we'll do an energy calculation in kilowatt hours in one moment. But first, what I'd like to do is I would like to see how many joules there are in 1 kWh. So this is going to be a little bit of train tracks. Okay, we're going to do a little bit of dimensional analysis here. Because what I have is I'm going to start with 1 kWh. And I know that 1 kilowatt is the same thing as 1,000 watts. So I have gotten rid of the kW part of this unit. I also know that 1 watt is the same thing as 1 joule per second. We talked about that last unit, the fact that a watt is the same thing as a joule per second. So I get rid of watts. And then I know that there are 3,600 seconds in 1 hour. So that gets rid of hours and that gets rid of seconds, leaving me with just the joules. So if I multiply everything on top and divide it by everything on the bottom, I should get my answer for how many joules there are in 1 kWh. And what we find is there are 3,600,000 joules in 1 kWh. Okay, so they are both measuring energy. Okay, I would like to emphasize that again. Both joules and kilowatt hours do measure energy, but they measure it in very different scales. So we are talking millions of joules in order to make up 1 kWh. And as we saw from before, right, if we're running just a single light bulb for one single hour, we already are in the thousands of joules. So the second advantage for your electric company, the second advantage for them putting their numbers into kilowatt hours is that it makes the size of the numbers much smaller and a little bit easier to deal with, so that your bill every month doesn't have numbers in the billions, which it might if everything was written in joules. Okay, but let's talk about the other advantage, right? Is that it can make energy calculations very simple. So if you notice, right, kilowatt hour, what we can do is we can find our power rating in kilowatts and just multiply that by how many hours we're going to use it. So let's do example 2 again, this time giving our answer in kilowatt hours instead of in joules. So our energy is going to be the kilowatts, and 60 divided by 1,000. I don't know why I've lost all confidence in my ability to do this. Yes, that is 0.06, okay, kilowatts, and we have that on for 1 hour. So the energy for that 60, this is the 60 watt light bulb, is going to be 0.06 kilowatt hours. That was pretty dang easy, wasn't it? Let's do the 13 watt light bulb, okay? How much energy is that 13 watt light bulb gonna do? Well, 13 watts is 0.013 kilowatts, and we are keeping it on for 1 hour. So this thing is going to use 0.013. kilowatt hours of energy. And that was so fast. And yet we get the same result, right? Like we get this same result where we very clearly see that this guy is going to be using less energy. This guy is using more energy. So if given the choice, we would prefer to use that 13-watt light bulb.